Hi students, have a nice day. In this section we are going to discuss about the thermodynamic process, internal energy, zeroth law, first law, etc. What is a process? The path or operation by which the system changes from one state to the another state is called a process. The path or operation by which a system changes from one state to the another state is called a process. Then the process which brings about the thermodynamic changes. Okay, the process which brings the changes in the thermodynamic state is called a thermodynamic process. There are several thermodynamic processes. Okay, one is isothermal process. Second is isobaric process. Third is isochoric process, adiabatic process, cyclic process, reversible process, irreversible process. Okay, let's discuss one by one. First one is isothermal process. Okay, isothermal process. First one is isothermal process. Isothermal process are the process takes place at a constant temperature. Okay, what are isothermal process? The process takes place at a constant temperature is called isothermal process. That means there is no change in the temperature. Okay. The process takes place at a constant temperature means there is not change in the temperature. Temperature must be constant. That means delta T, that is T2 minus T1, or you can write that delta T is equal to T final minus T initial, and this delta T is equal to 0. For isothermal process, the change in the temperature do not take place. That means initial and final temperatures are same, and T2 minus T1 is equal to 0. Delta T becomes 0. For a small change, dt is equal to 0. Okay, delta T means change in the temperature. If a temperature change is very small, dt, we write dt, dt is also equal to 0. That is called isothermal process. Second one is isobaric process. Isobaric process. The isobaric process takes place or occurs at a constant pressure. The process takes place at a constant pressure is called a isobaric process. That means the pressure is constant. The pressure kept constant. The process is called a isobaric process. For isobaric process, delta P, the change in the pressure, P is equal to P2 minus P1. Also you can write that P final minus P initial. Similarly, delta T is equal to T final minus T initial. And this delta P is equal to 0. Not change in the pressure. That means initial and final pressure are same. Okay. So delta P is equal to 0. For a small change, dP is equal to 0. Okay, dP is equal to 0. And the third process is isochoric process. Okay, the third process is called isochoric process. Isochoric process. What is isochoric process? Isochoric process means the process takes place at a constant volume. Okay, the volume must be constant. The process takes place at a constant volume is called isochoric process. For isochoric process, delta V is equal to V2 minus V1. that is equal to 0. Okay. Delta V is equal to V2 minus V1 or V final minus V initial and is becomes 0. For a small volume change, dV is equal to 0. Okay. dV is equal to 0. Are you clear? Yes. Then the fourth process is adiabatic process. Okay. Adiabatic process. Adiabatic process means the process takes place at a constant heat energy, constant heat. That means the system doesn't lose or gain heat energy. The process takes place at a constant heat. A is called a adiabatic process. The heat energy is represented by the letter Q. Okay. Heat is represented by the letter Q or simple Q. For adiabatic process, okay, adiabatic process, delta Q is equal to Q2 minus Q1, that is equal to 0. For small change, dQ is equal to 0. That is adiabatic process. Okay, adiabatic process. So, a very simple concepts: isothermal, isobaric, isochoric, adiabatic. And the fifth process is cyclic process. Okay, the fifth process is cyclic process. In cyclic process, the system starts from the initial state and regain its initial state after several operations. Okay, the system starts from initial state or initial stage and it regains the initial state after several operations or series of operations. Okay, that is called a cyclic process. The fifth one, cyclic process. Let's take a system with a pressure P1, a volume V1 and a temperature T1. There is a thermodynamic variable. Okay, pressure, volume, temperatures are thermodynamic variables. You know that. In the last section we discussed. So a system starts from the initial stage. This is the initial stage. And it changes into P2, V2, T2. And it's again changes into P3, V3, T3. Finally, it reaches the initial stage. Okay, it reaches the initial stage P1, V1, T1. Okay, starting from P1, V1, T1 and it reaches again P1, V1, T1 as across or several operations are in the initial and final state. So such a process are called a cyclic process. Okay, as you know that carbon cycle, nitrogen cycle, the initial point and the final points are same, but the process takes place in several operations. Okay, several operations are there, but initial and the final state is same. That is called a cyclic process. Okay, the next is reversible process. Okay, reversible process. A reversible process takes place at infinitesimally small steps. Okay, infinitesimally small step. That is very, very small steps. Okay, reversible process takes place at infinitesimally small steps. And it takes infinite time to complete the process. Okay, and it takes infinite time. And all these infinite small steps are in equilibrium. Okay. By changing any one of the thermodynamic variables, the forward process can be changed into the reverse side. And the driving force is very, very small as compared to the opposing force, or opposing force is small as compared to the driving force. Okay, let's take one simple diagram, a reversible process. Okay, reversible process. Okay, the process takes place at A to B. Okay, A to B, and all these process in a small steps, infinitesimally small steps. Okay, from A to B. Okay, from A to B the process changes from A to B, and it takes place at infinitesimally small steps. First step, second step, and these the steps are equilibrium. The steps are equilibrium with each other by changing any one of the thermodynamical variables. We back into the initial state. Okay, and the opposing force is smaller than the driving force, or very small change between the opposing force and the driving force. Driving force means the force which drives into the forward direction. Okay, and an opposing force is there. So these two forces, the change is very small, and that's why I told you a reversible process is taking place at infinite time. Okay, so once again, a reversible process takes place at infinitesimally small steps. Each steps are in equilibrium with each other. By changing the thermodynamic variable, we back into the process is changed into the reverse side. The opposing force is very small as compared to these opposing force and driving force changes is very small. And one more thing, it is a hypothetical process. It is a theoretical process. In practice, the process not takes place because it takes place at infinite small steps, or the time is infinite. Okay, the time for reversible process is infinite. Okay, so that's why it is a theoretical process. Another process is irreversible process, a very simple process. Is a reversible process takes place at infinite small steps, and it having infinite time. The irreversible process takes place rapidly, very fastly. Okay, the seventh one is irreversible process. Irreversible process. Irreversible process takes place at rapidly. The process takes place rapidly. It is called a irreversible process. Okay, it is called a irreversible process. All the natural process are irreversible. Okay, all the natural process are irreversible. You remember that. So that's about the thermodynamic process. Isothermal, isobaric, isochoric, adiabatic, cyclic, reversible and irreversible process. So you should learn this concept, because in problems the question is like that. In an adiabatic process or for isothermal process, like that the question comes. So understand that isothermal process means the temperature must be constant. There is not change in the temperature. For isochoric process, the volume change must be zero. The volume kept constant. Yes, next we discuss the Zeroth Law. or law of thermal equilibrium. Why the law named as a zeroth law? This law is formulated after the proposal of first law of thermodynamics, and the law is considered to be a primary importance. Okay, the law is proposed or formulated after the proposal, the first law, and this law is considered to be primary importance. That's why the name is given zeroth law of thermodynamics or law of thermal equilibrium. It's a very simple. Let's consider the three system A, B, C. Okay, A is in thermal equilibrium with a V. A, the system A is thermal equilibrium with a V. So A and B are thermal equilibrium. That means the temperature of A and B is same. And a system C is thermally equilibrium with B. Okay, B is thermal equilibrium with C. Then the system A and A and C are in thermal equilibrium. Okay, a very simple concept. The law is states that if two systems are thermally equilibrium and the third system is thermally equilibrium with one of the system, the system second is thermally equilibrium, as well as the second and the third system are in thermal equilibrium. Okay, so very simple concept. A is thermal equilibrium with B, B is thermal equilibrium with C, then only A is thermal equilibrium with C, because the temperature of A and B is same and the temperature of B and C is same. That means A is thermal equilibrium with B, B is thermal equilibrium with C, and then the A become thermal equilibrium with C. Then what is the importance of this zeroth law? Zeroth law is helpful to determine the temperature of a system. Okay, zeroth law is very useful to determine the temperature of the system. Okay, are you clear? Yes. Then when we kept thermometer in a hot body, the heat flow from hot body to the thermometer and the mercury level increases. That means after some time the temperature of the body and the thermometer is same. That's why in clinical process the thermometer kept for some time in our body. Okay, after reaching the thermal equilibrium, the temperature is measured. Okay, the nurse not just touches the thermometer into our body, it's kept for some time. For what? The body and the thermometer are in equilibrium. It takes some time. And then only he or she measure the temperature. In advanced digital thermometer, a beep sound is here after reaching the equilibrium. Okay, as earlier, mercury thermometer is used. Okay, then what happens when this thermometer is dipped in a ice cold water or in an ice? Okay, the level of the mercury decreases. That means that the heat flow from thermometer into the ice, and that's why the level of mercury decreases. So zeroth law, only one importance, it is helpful to measure the temperature of a body. Okay, then next we move to the internal energy. Internal energy means the total energy stored in the system. Okay, the total energy of the system is called internal energy. What is internal energy? The total energy of a thermodynamic system. Okay, the total energy of a thermodynamic system is called internal energy. Internal energy. And is represented by energy. U, the symbol U, not E. Okay, internal energy is represented by the letter U. What is U? U is the sum of all type of energy in the system. Okay, or in the thermodynamic system. What is internal energy? The sum of all types of energy in the system. That means energy of translation. Okay, energy of translational energy. Energy, ET means translational energy. Then rotational energy. Rotation, R, rotational energy. Then energy of vibration. Energy of electronic excitation or electrical energy. Kinetic energy, okay, EK. Potential energy, EP, etc. Okay, many energies are in the system. The sum of all the energies is called internal energy. And you understand one thing, the absolute value of internal energy cannot be calculated. Okay, the absolute value of, the correct value of internal energy cannot be accurately calculated. Why? It is a sum of a lot of energies. It is a sum of many forms. Okay, so that's why we cannot determine the absolute value. But we can determine the change in the internal energy. Okay, delta U can be determined, that is U2 minus U1. Or you can write that internal energy delta U, the change in the internal energy delta U is equal to U final minus U initial. Okay, U final minus U initial. And we can change the internal energy. Okay, by give heat energy into the system or drain heat energy from the system. So internal energy can be changed. Heat is supplies into the system or takes from the system. Internal energy changes. Okay, and another change is made by work done. Work done on the system, work done by the system. It changes the internal energy. Okay, the internal energy is changes by doing some work. Work done on the system. The work is given into the system. That is work done on the system. And work done by the system. The system do some works. That also changes the internal energy. Okay. And another is matter is enter into the system or matter leaves from the system. So enter or leaving the matter. The matter enter into the system or matter leaves from the system, internal energy is changed. And internal energy is a state function. It depends the initial and the final state of the system. Not the path, how to reach. The root of the change doesn't affect the internal energy. That means a work done is a path function. You know that work done is a path function, but internal energy is not a path function, it is a state function. Okay, and also it is an extensive property. And the last section we discussed that intensive property and extensive property. Extensive property which depends the quantity of matter. Okay, extensive property depends the quantity of matter. Intensive property independent of quantity of matter. So here internal energy is extensive property. That means the amount of matter, the amount of substance in the system depends the energy change. Okay, that's why we can say that the change in the internal energy can be done by matter is enter into the system or matter leaving from the system. Okay, are you clear? So that's about the internal energy. Internal energy is the total energy of the system, thermodynamic system. It is a sum of all types of energies in the system. What are the different types of energies? Translational energy, rotational energy, vibrational energy, electrical energy, then kinetic energy, potential energy, etc. Mechanical energy also there. Okay, so many energies are there. All energies summed up, we get the internal energy. Internal energy is an state function. Okay, it is a state function and is extensive property. Okay, and the absolute value of internal energy cannot be calculated because it is sum of many energies. But we have to determine the change in the internal energy. Okay, internal energy. And one important thing, if the heat energy is supplied to the system, we take it is a plus Q. Okay, heat energy or heat is given into the system. Heat energy given to the system. It is positive Q. You remember that. It is useful in the problems. And heat energy liberates by the system minus Q. The value is taken as minus. That's enough. Okay, heat is absorbed, given to the system or absorbed by the system. Absorbed by the system plus Q. Are you clear? Yes. Similarly, work done on the system. Work done on the system, it is positive work. Work done is represented by W. Work done by the system. Work done by the system, it is minus W. Okay, work done by the system, it is minus W. So this convention is very important. Heat absorbed by the system or heat is given to the system. Okay, given to the system, it is plus Q. Heat liberates or heat removed from the system, it is minus Q. It's very important. And work done on the system, you give the work to the system, it is positive W plus W, or it is positive work. When work done by the system do some works. Okay, the system do some work, it is called minus W, a very important thing. And also you understand that two type of works are there, mechanical work and electrical work. Electrical work is due to the movement of ions or electrons. Electrical work is takes place like that. And mechanical work is due to the change in the volume. Okay, the mechanical work is due to change in the volume. Okay, and W for a mechanical work, W is equal to P delta V. A very important. For mechanical work, W is equal to mechanical work. W is equal to P delta V. Okay, P delta V. Are you clear? And W adiabatic is there. W adiabatic means the work is done, but there is no change between the heat change between the system and the surrounding. Okay, if there is no heat change between the system and the surrounding, and work done takes place in the system, the work is called adiabatic work and is represented by WAD. Okay, adiabatic work. Reversible work is there, irreversible work is there. Okay, so many works are there. We will discuss later. So now we understand that mechanical work. Okay, mechanical work. For mechanical work, W is P delta V. Okay, the derivation is no need. One derivation is given in the textbook. It is no need to study. You just understand that W is P delta V. Then what about work done by the system? Work done by the system, W is P delta V by the system. Why? Work done by the system, W is negative. Then work done on the system, work is given into the system, W is P delta V itself on the system. Work done on the system. Okay, so that's about the work and the internal energy changes. Then first law thermodynamics and its application we will discuss in the next section. Thank you.